Hi everyone, this video is going to be on function operations, but before we get into some problems, I just want to go over the basic math operations. So we have plus, minus, times, and divide. In math, if you're told to add or subtract, you'll always see those actual symbols. However, when you're told to multiply or divide, you won't necessarily always see those symbols. So other things that you might see when you're multiplying are the dot or even parentheses. I'll show you in these examples that the parentheses don't actually represent multiplication when you're looking at functions. So really, for these problems, we're going to be looking at the dot. And then with division, we can also represent that as like a fraction. But we're not going to see division in these examples. All right, so in these examples, I'm going to show you how to add, subtract, and multiply these functions. The problem states, let f of x equal 2x squared plus x minus 3, and let g of x equal x minus 1. And then you are to perform the indicated operation. The first one says f plus g of x. So what that means is f of x, so this whole expression, plus g of x, which is this expression. Okay, so I'm going to rewrite that 2x squared plus x minus 3, and I'm going to add the x minus 1. From here, I'm just going to combine like terms. So 2x squared, nothing else has a square on it, so I'm just going to rewrite that in my final answer. This plus x goes with this other plus x. So there's like an imaginary 1 in front. So really have like 1 plus 1, which is plus 2, plus 2x. Then I have this negative 3 and this negative 1. So minus 3, or negative 3 minus 1 is negative 4. So basically what we did is we combined two expressions to make one. Okay, number 2 says f minus g of x. So this means f of x minus g of x. So f of x, this whole thing, minus this thing. So I'm going to rewrite that, 2x squared plus x minus 3, that's f of x, and then I'm subtracting the x minus 1 from g of x. So x minus 1. I put parentheses around that because we need to remember that when we're subtracting an expression, we're not just subtracting the first term, we're subtracting both terms. So I'll write that in the next line. So 2x squared plus x minus 3 minus x, so minus x, and minus negative 1. When I'm doing minus a negative 1, I'm really just thinking about the opposite of negative 1, which is positive 1, so plus 1. You can also think of that as negative 1 times negative 1, which gives you a positive 1, okay? So that's why we put the parentheses around it when we're subtracting, because we have to remember to subtract both pieces. Okay, so now I can combine like terms, 2x squared. This x goes with this x, but that's a positive x and a minus x. This is like a positive 1 and a minus 1. 1 minus 1 is just 0. So really, these two things cancel. Now I'm left with this negative 3 and a positive 1. Minus 3 plus 1 is negative 2. So this is my final expression when I subtract x minus 1 from this expression. Okay, and number 3 says f times g of x. So that is the same as writing f of x times g of x. Okay, so I'm going to take this expression and I'm going to multiply it by this expression. So 2x squared plus x minus 3, all of that being multiplied by x minus 1. When I'm multiplying, I have to do the most steps because I have to multiply every piece, right? This 2x squared has to be multiplied by the x. It also has to be multiplied by the negative 1. This positive x, right, has to be multiplied by this x, and it has to be multiplied by this negative 1. This negative 3 has to be multiplied by the x and the negative 1. So multiplication is going to be the longest type of like operation that we do, because we have to multiply all of these pieces. In order to get all of those pieces, I like to use the box method. So I'm going to draw a box that's a 2 by 3. And it's a 2 by 3 because I have 2 terms here and I have 3 terms here. So now I'm going to line up my terms. So 2x squared plus x minus 3. Okay, and then on the side where I have 2 terms, so 2 rows, I have an x and a negative 1. When I go inside the box, I have to multiply. So in this first box, I'm multiplying x times 2x squared. So the x here and the 2x squared here. Okay, what that means is x times 2x squared is the same as x times, or 1x, right? Because there's an imaginary 1 in the front, times 2x times x. 1 times 2 is just 2. X times x is x cubed. So inside here is 2x cubed. In the next box, I have x times x, because I have this one going here and this one here. So x times x, I'm multiplying it twice, so x squared. In this box over here, I have x times negative 3, which is just negative 3x. Then over here, I have negative 1 times 2x squared. Negative 1 times 2 is negative 2. And then the x squared tags along. In this box, we have, this should be red, so I'm just going to write over it. Okay, in this box, we have negative 1 times x, which is negative 1x. And then over here, we have negative 1 times negative 3. Negative times a negative is positive. So negative 1 times negative 3 is positive 3. All right, so I multiplied to go inside the box. Now when I pull these terms out of the box, I'm adding. So I'm just going to line them up. 2x cubed plus x squared minus 3x minus 2x squared minus 1x plus 3. Okay, and now I have to combine my like terms. 2x cubed doesn't have anything else with an x cubed, so I'm going to bring it down to my final answer. This plus x squared is going to combine with the negative 2x squared. Remember, this is an invisible 1, so 1 minus 2 is negative 1x squared. Then I have this negative 3x and a minus 1x. Negative 3 minus 1 is negative 4x, and the positive 3 doesn't combine with anything, so we just bring it down. And this is my final answer for multiplying. Okay, let's look at these examples. So it says, let f of x equal 2x plus 5 and g of x equal x squared minus 3x plus 2. And it says, perform each function operation. Number 1 says, negative f of x plus 4 g of x. So these problems are different from the ones that we saw in the previous slide because I'm doing extra steps before I can actually add them together. Okay, so before I can add f of x and g of x, I have to first subtract f of x, or take the negative of f of x, and I have to times 4 by g of x. So I have to do those 2 steps before I can even add them together. Okay, so we're going to write that as negative or minus 2x plus 5 plus 4 times g of x, which is this whole expression. So x squared minus 3x plus 2. And also we brought f of x down here. G of x here. Okay, so we have negative 2x plus 5. So it's not just negative 2x, it's both pieces that are being subtracted, or taking the opposite of. So taking the opposite of 2x is negative 2x. The opposite of positive 5 is negative 5. And again, you can think of this as multiplying by a negative 1. Okay, so negative 1 times 2x is negative 2x. Negative 1 times 5 is negative 5. Okay, and then I have to take 4 times that expression for g of x. Well, I'm not just taking 4 times x squared, I'm taking 4 times every single piece. So this, I need 4 times of the x squared, 4 times of the negative 3x, and 4 times of the positive 2. So again, it's like distributing that 4 to all your terms. So 4 times x squared is 4x squared. 4 times negative 3 is negative 12x. And 4 times 2 is positive 8. From here, I'm going to combine like terms. So negative 2 goes with the negative 12. Negative 5 goes with the positive 8. And the 4x squared doesn't have anything to combine with. I'm going to write 4x squared first, so that my expression, my final expression, is in standard form, which just means that the exponents go from greatest to least. Okay, so 4x squared, then negative 2x, so right here, and negative 12x. When I have a negative and I'm going more negative, it's like adding those two together. So I get negative 14x. Then I have this negative 5 with the positive 8. So that's like 8 minus 5, which is positive 3. And this is my final answer. The next problem says f of x minus 2 times g of x. So I'm going to write that as f of x, which is 2x plus 5, minus 2 times this expression. So I'm going to put that in parentheses, x squared minus 3x plus 2. Okay, and then I'm going to bring down the 2x plus 5, and then I'm going to subtract off 2 of the x squareds, 2 of the negative 3x's, and 2 of the 2's. Okay, I need this 2 to basically distribute to all 3 terms, because I'm not just subtracting 2 times x squared, I'm subtracting 2 times all of it. So minus 2x squared. Negative 2 times negative 3 is positive 6x. And negative 2 times 2 is negative 4. Now I combine like terms. The 2x goes with the positive 6x. The 5 goes with the negative 4. And 2x squared, negative 2x squared doesn't have anything that it combines with. So I'm going to write negative 2x squared. 2x plus 6x is 8x. Negative 5, or positive 5, and a negative 4 is 5 minus 4, which is positive 1. And that is my final answer for this.